Good morning, everybody. I hope everybody has been staying warm, and I hope you guys have a great day today. It's a great day to learn about function notation in Algebra 1, I can tell you that. But we are moving on to Chapter 3, Section 3, Function Notation. So let's just get started. You know that a linear function can be written in the form y equals mx plus b. You guys have seen that before. That's just a linear form of an equation of a linear function. By naming a linear function f, you can also write the function using what we call function notation. So this is our function notation right here. And these parentheses right here do not mean multiplication in this case. This stands for f of x. So the notation f of x is another name for y. We treat f of x the same way we treat y. It's just another way to write it. So if f is a function and x is in its domain, then f of x represents the output of f corresponding to the input x. You can use letters other than f to name a function, such as g or h. We can use h of x, g of x, h of t, f of t, so on and so forth. But I do want to reiterate, this is not f times x. This is what we read it as f of x. It's function notation. So f of x equals mx plus b would be function notation for a linear function. So let's look into some examples and talk about it a little more. It's not a whole lot different than y. Like I said, we treat f of x just like y. So it says evaluate f of x equals negative 4x plus 7 when x equals 2 and x equals negative 2. We're going to do the same thing we would do even if this was y equals negative 4x plus 7. If it tells us to evaluate when our x values equal some number, we just plug these numbers in for our x variable. So we're going to do the same thing even though it's in function notation. So we're going to evaluate when x equals 2. So if you notice, there's an x here and an x here. I'm going to replace all my x's with 2. And now I'm just going to work down the right side of my equation using my order of operations. I'm going to do my multiplication first. Negative 4 times 2 is negative 8. Still have that plus 7. Negative 8 plus 7 gives me negative 1. So f of 2 is negative 1. Please, please, please don't try to divide by 2 on the next step. Because once again, that is not multiplication. We're evaluating our function when x equals 2. So we would just say f of 2 equals negative 1. And that's where we stop. It also wants to evaluate it whenever x equals negative 2. So once again, I'm going to replace all my x's with negative 2. So I have negative 4 times negative 2 plus 7. Negative 4 times negative 2 is positive 8. 8 plus 7 gives me positive 15. So I would say f of negative 2 equals 15. That's the exact same thing we would have done if the f of x was just replaced with y. You guys have done that before, so hopefully that's not too much of a new concept where it should be earth-shattering for you. And let's look at the next example now. Interpreting function notation. So our example says let f of t be the outside temperature in degrees Fahrenheit t hours after 6 a.m. Explain the meaning of each statement below. So letter A. We have f of 0 equals 58. It wants me to explain the meaning of that statement using all the information that I've been given up here. Okay? So, T is the number of hours after 6 a.m. So if I'm doing f of 0 instead of f of t equals 58, f of 0 is meaning 0 hours after 6 a.m. So we could say the temperature was 58 degrees Fahrenheit at 6 a.m. That'd be my interpretation of letter A. That's my initial value of the function, because t stands for the hours after 6 a.m. So if my t is 0, that's 0 hours after 6 a.m. So I could say the temperature was 58 degrees Fahrenheit at 6 a.m. Now let's look at letter B. So now we're saying f of x or f of 6 equals n. So once again, that t value, in this case 6, is the number of hours after 6 a.m. So 6 hours after 6 a.m. would be 12 o'clock or noon. So what this is saying is at noon, or 6 hours after 6 a.m., it was in degrees Fahrenheit. It doesn't give us a value for n, so we just say it's in degrees Fahrenheit. And letter C, f of 3 is less than f of 9. So once again, those numbers in parentheses, 3 and 9, stand for the number of hours after 6 a.m. So f of 3 is talking about 3 hours after 6 a.m., which is 9 o'clock a.m. 9 is standing for 9 hours after 6 a.m., which would be 3 o'clock p.m. So here what this statement is saying on letter C is the temperature at 9 a.m. was less than the temperature at 3 p.m. because it's saying f of 3 hours after 6 a.m., which is 9, is less than f of 9, which is 9 hours after 6 a.m., which would be 3 o'clock p.m. So the temperature at 9 a.m. was less than the temperature at 3 p.m. Hopefully that makes sense. Let me know if you guys have any questions on that one. That one can be a little tricky sometimes. Example 3. Solving for the independent variable. Excuse me. So once we talked about independent dependent variables a few lessons ago. Our x variable is our independent variable, and our y variable, or in this case h of x, is our dependent variable. So it says for h of x equals 2/3 x minus 5, find the value of x for which h of x equals -7. Now, a few examples ago, it wanted me to evaluate the function when x equals 2 and x equals -2. So I replaced the x with 2, and I replaced the x with -2. Here it wants me to find the value of x for which h of x equals -7. So instead of replacing the x with -7, h of x equals -7, so I'm going to replace h of x with -7. And now I'm solving my equation for x, trying to get the x by itself. So I'm going to add 5 to both sides. -7 plus 5 gives me -2 equals 2/3 x. 2/3 is being multiplied by x, so I divide both sides by 2/3. And that would give me x equals -3, I believe. Type it in my calculator real quick. Yep, x equals -3. So the value of x for which h of x equals negative 7 would be x equals negative 3. So once again, you got to pay attention to what they're asking in the question. In this case, we wanted to replace our h of x with negative 7 instead of our x value, whereas our first example wanted us to replace our x value with the number it told us. So make sure you really read the directions and pay attention. Last example here real quick. Graphing a linear function in function notation. We've graphed equations that had a y variable in them. We've made a table of values, and I'm going to do the same thing here. Remember, we treat f of x like y. So I'm going to create a table of values, and instead of having y, I'm just going to have f of x. So I'm just going to pick some random x values to plug in. First x value, I'm going to plug in negative 2. So I just replace my x value with negative 2 and evaluate it. 2 times negative 2 is negative 4. Negative 4 plus 5 gives me positive 1. So my f of x value would be positive 1 there. Now I'm going to plug in negative 1 and evaluate. 2 times negative 1 plus 5. 2 times negative 1 is negative 2. Negative 2 plus 5 is positive 3. Now I'm going to use 0. 2 times 0 plus 5. 2 times 0 is 0. 0 plus 5 is 5. Now I'm going to plug in the number 1. 2 times 1 is 2. 2 plus 5 is 7. I'm going to plug in one more number. I'm going to plug in the value 2. 2 times 2 is 4. 4 plus 5 is 9. So a lot of times I like to use just these 5 values because it gives me 2 in the negatives, 2 in the positives, and 1 at 0. But these are just random x values to plug in to get your graph, to get your ordered pairs. So you just pick some random x values to plug in to get some ordered pairs to be able to graph your function. So let's graph it real quick. I'm just going to graph those ordered pairs that I found. First one will be negative 2, 1. So I'm going to go left 2, up 1, put my point. Next one is negative 1, 3. So left 1, up 3, put your point. 0, 5. I'm not going left to right any. I'm just going up 5. 1, 7, right 1, up 7. And then 2, 9, right 2, up 9. So I've graphed the some ordered pairs on my line. So now what I can do is I can just connect my points with a line and put arrows on my line. And there would be the graph of f of x equals 2x plus 5. So that's how we would graph this. We'd create a table of values to get our ordered pairs, graph our ordered pairs, connect the points with a line. I hope most of this made sense for us. I don't think this one would be too hard for us, but if it is, that's not a problem at all. Just make sure you're asking me questions. That way we can get the problems resolved and we can get you to understand it. So make sure you're watching this video, taking these notes. Our assignment for today is page 127, numbers 1 through 27 odds. Let's have this do... Let's have it do Friday, which will be the 12th. So tomorrow. Do tomorrow the 12th on Canvas. Once again, if If you don't understand something, make sure you're asking me. That way I can help you. Hope you guys have a great rest of your day. Make sure you're knocking this out. We'll see you guys next time.